Today, we are going to be talking about indices. Indices. First law of indices. Other textbook may try to categorize years in different ways, but this is what I am doing. Okay, let me say, if I don't use this, as A, let me just use X. We like using X in mathematics. X times S raised to power. So what this law simply tells us is, when we multiply similar base, what we do is that we add their power. Multiplication of similar base, don't forget, if it is xy, maybe this one is 2, this one is 3, we don't add their power, don't forget that. I'm going to give you an example to show what I'm talking about. So, whenever we add similar base, we add their power and we take that similar base, just one of that similar, just take the base and add their power. So what we have succeeded in saying is this. What we are saying is, so we have added their power and we take the similar base. The similar base is x in this case. When it is in multiplication form like this, it is not the same thing we do. So I've seen somebody who said you need to apply indices here. This one is addition. No, this is not indices. Indices is when you are multiplying a number that have power and they have similar base, then you add their power, you take that similar base. If it is even more than 2 like this, you can also say, for instance, x a times x b times x c. If you go on and on like that, you just to take the similar base, where we now say a plus b plus what? C. This is what we're talking about. So irrespective of the fact that we are having 2 or more than 2, even as much as they are the same base, we just add their power, and it must be in multiplication form, not addition, not subtraction. So it is when we multiply number with similar base, we add their power. I will give you an example under this, simple examples under this. Example 1. Example 1, let me say x, like I just started using, let me say 2, let me say 5. Let me just give a very simple question. X raised to power 2. When we do this, we are going to see very simple. X is equal to 5 raised to power. X is equal to 5 raised to power minus, 5 raised to power, x raised to power 5 plus 2. X raised to power 5 plus 2, according to what the law tells us there. So this is just a simple thing about the first law of physics, when we add their power. While we talk about this, please don't forget that when you have a number, for instance, like this, let me say x, maybe x2, x5. You don't need anybody to tell you that this number you are seeing here, it's multiplication. Whether we write it like this, okay, maybe I will use something else to illustrate what I'm talking about. I will use, anyone will get what calculation what I'm talking about. So what you have is the similar base, you add their power. Let me give other examples again. Let me assume that we have example 2, where we now have 5 times x raised to power minus 2. In this case, don't forget that irrespective of the fact that we have minus sign there, it's not our business. We are going to apply the law accordingly. Similar base, 5 plus, because we are going to add the power, minus what? 2. We're not removing the minus sign there, but we have to apply the law first before we talk about what will happen to that one later. When you go to my algebra, my video on algebra, I think in that video I explain what is happening there. In this case, we cannot use the plus and minus at the same time. So rather we now see x raised to power 5 multiply minus times plus, now give us minus. So we now see 5 raised to power minus 2, where we now add x raised to power 3, x raised to power 3. So you can see what is happening there. X raised to power 3. So it's as simple as this. Applying the law Don't mind whatever you are seeing there, like you can see this one is having minus sign. You don't jump into the minus sign like that, because you have to obey the principle that guides that law. Then we want to talk about, okay, let me talk about second law of indices. Second law of indices. Second law. Second law. In the case of second law, we have division of similar base. Division of similar base. In this case, you know what this one means is actually a s raised to power a, s raised to power b. That's what it means. The same thing with this. Then by interpretation of the law is that when we have division of similar base, we subtract their power. Division of similar base, we subtract their power with a similar base. A minus b. This is exactly what we're talking about. There's something I want to actually bring here. There are so many people that know that this second law of indices is equal to this, but they always forget to know that this one, this x raised to power b a minus b, is the same thing as s raised to power a over s raised to power b. You must know how to do this, because there are calculations that will demand your knowledge on this. If you don't know it, you will just be there thinking that it's a very difficult question you're solving. But you must know that you must have the ability, even the first law, the same thing with the first law. You must have the ability of taking what that law has given you to where it's coming from. What you are seeing here is s raised to power 5 plus 2. It also means s raised to power 5 times s raised to power 2. You must know this, that this one is equal to this. You must know that. If you don't know it, you have problem with some calculations. You must know what the law gives you can also come back from where you got to in the law. Let's solve some questions. Example 3. Yes, still on indices. Let's assume that we are having x raised to power 5 divided by x raised to power 2. Let me say 3. We are used to before raised to power 3. By this, we already know that it's going to be x raised to power 5 minus 3. This gives us x raised to power 2. This is exactly what we are going to have. Knowing fully well that we have this similar base and we have division there, and we are going to subtract their power. Don't forget that this is as simple as this. And don't forget that this is also equal to this. You should be able to take it back and forth. Take it to this form and also back to this form, which is also the same. Also put it in the division form like that. Whatever way you want to put it, it's a very good thing that you need to know. Number 4, example number 4. Okay, I want to involve minus signs in my calculation so that you will know the reason why you must understand the law properly. X raised to power, let me see, minus 5 divided by x raised to power minus x raised to power minus 2. In this law now, x raised to power minus 2. In this law now, you're going to see something here that some people are easily carried away with the minus sign they are seeing there, forgetting that the law in itself has a minus sign. You have to apply the law, don't mind whatever you are seeing there. So you now have x raised to power minus 5. Don't forget, the law says that we're going to subtract their power. Then it has to come with the minus sign. The minus sign that was there before, you still use it. You don't throw it away. Like somebody told you that you throw it in the dustbin. No, you don't throw it away. You must acknowledge that minus sign that was there before. You must apply the law the way it is and acknowledge that it was having a minus sign there before. And like I said earlier, my algebra, the video on algebra that I have before, you check, you see, I taught how to handle situations like this. Here we are going to have minus 5. We cannot deal with these two signs in between that number like that. What you must do is that you must multiply the two signs first before you go on with the calculation. And when we do that, we have what? Minus 5 plus 2. So from that same algebra, and what we are having here, we will know that I'm going 5, I'm having 2. I'm going to be going at the end of the day, I'm still be going 3, which makes it minus 3. Go back to that algebra, you see my explanation about what is happening there. Those are things that you need to know and build yourself in mathematics. I think with this, we've been able to pass on our lessons. We talked about the first law, talked about the second law. Then the third law, I will stop with this for now. The third law is very simple. What the third law is telling us is very, very simple. Third law of indices. Third law of indices. What the third law is telling us about is that anything raised to power 0, whether it is x, whether it is a, anything, 100, the number, numerical, alphabet, or whatever, anything raised to power 0 is equal to what? 1. Anything anywhere, whether Q, whether arrow, whether P, whatever, whether it's 1 million, any number raised to power 0 is equal to what? 1. Some people do not know that these things are used during when they are doing number bins. When you see that they now have raised to power 0, they now say it's 1. How did they arrive at that? They don't know. That is the law that is you are seeing there. It is the third law of indices. So get that very clear that anything raised to power 0 is equal to 1. It's as simple as that. I asked the person some time ago, example what is this? Example 5. Let me assume 2x raised to power 0. The person said 2 is equal to 0 because he did not take note of the fact that this 0 raised to power 0 was not affecting 2, it was only affecting x. So now 2 times what? 1, because it's x raised to power 0. Anything raised to power 0 is equal to 1. So now what? So you didn't take note of that. So this is exactly what we're doing, but you have to apply the law. This one can only be right if we have something like this example 6. Where we say 2x all in brackets raised to power 0, everything becomes what? 1, because everything is in bracket. Anything raised to power 0, whether since they are in bracket, even if it's many things that you have, maybe 2x, y, z, whatever, all raised to power 0 in bracket. In as much as it's all in bracket raised to power 0, everything becomes 1. So get this note in this video. In our other videos of indices, I'm going to teach you the other laws, like the fourth laws, the fifth law, the sixth law, then indicial equations. If you follow up on these videos I'm going to be posting, and you know for sure there's no way you do not have a clear understanding of indices. See you in our next video. Thank you very much.